All right. Trying out question 2 of the homework again for the second time because we keep making the mistakes all the time. Anyways, we're given the initial velocity of the truck, 50 kilometers west, 60 degrees north, and the final velocity. And of course, what we need to do is subtract the two vectors, subtract the two velocities to find delta v, or the change in velocity, divided by the change in time, which is a quarter of an hour, and that calculates the acceleration. So the trick we seem to be having is trying to keep it sorted out, what things to turn negative and what things not to turn negative. So we're going to draw this truck careening down the highway at 50 kilometers an hour at 60 degrees north of east, and then we are going to do the calculations for that. So there we go. There's the, oh, did I say 60? I meant 50 kilometers per hour. And so there's our initial vector, and we are going to break it into vi in the x direction and the initial velocity in the y direction using SOHCAHTOA. And of course, it has the benefits of being one of these nice 60-degree triangles. So I know for sure that this one is 25 kilometers per hour, and that is west. Make sense so far? Okay. This one is 50 times the sine of 60, and this is going to be in the westward direction. So if I did 50 times the sine of 60, 43. Did you say 43?
I did say 43.
Okay. What if I told you I didn't believe you? Yeah, you're wrong. It's 43.3.
Oh, shoot.
I'm even going to write it out just to be a jerk. Okay. So we're going to keep a little list of our VI x's and our VI y's. So VIX is going to go up here, 25 kilometers per hour, and that is west. And our VIY is going to go here, and this is 43.3 kilometers an hour north. And the trick is that we need to turn these into negatives and make sure we've got our directions correct when we go to add the VIF. So now we're going to go to the VIF, the final velocity of the truck as it careens down the highway. Now this is a much more interesting problem than they originally laid out. They didn't mention that this was a dynamite truck. Does it say it's a dynamite truck?
I think so.
Okay, so 80 kilometers an hour, and that is east, 60 degrees to the north. And since it's a nice 60-degree triangle, this is 40 kilometers an hour, and that's east. And this is 0.8669 times 80, so this is
69.
69. Okay, so this is VFX, and this is VFY here. So VFX is 40 kilometers per hour east, and VFY is 69 kilometers per hour north. Okay. Now, I could make this negative 25 kilometers an hour west, or I could just make it 25 kilometers per hour east. So I've made it negative VIX, so I can do the subtraction. Now this one is already headed north, as is this one. So what I'm going to do, rather than change the direction indicator there, I'm just going to leave it as north and put a negative up here. Now I'm going to calculate delta V in both directions. So delta V X, I'm going to get rid of this triangle because that truck is carrying dynamite. I don't want it to go off. Okay, and so VFX minus VIX is 65 kilometers per hour east. And I can see that it was going west and then it switched and it's going east. So yes, this makes sense. Okay. And then delta VY, negative 43.3 plus 69. And this is going to be
25.7.
5.7 kilometers an hour north. Okay. So there are my two delta V's. Now I'm going to put it together. And I'm really hoping that this works out well. I think it's working, not like last time. Okay, so I'm going to make my triangle. So this is going to tell me my actual change in velocity when I add these two components. And so this one is 65 kilometers per hour. This one is 25.7 kilometers per hour. And so this is equal to, this magnitude. So I'm going to put the absolute value brackets around it. 65 squared plus 25.7 squared.
So 65 squared is 4,225. 65 squared.
Yeah, just give me the whole deal.
Turn my phone sideways and everything. Plus 4,885.5. That's all thing.
And then we take the square root of that.
69.89.
Really? 69.89 kilometers per hour. And now, to find theta, we're actually going to do the arctan of 25.7 over 65.
21.57.
21.57 or 22 degrees. Okay, so there's our direction. There's our magnitude. This is our delta V. So A is equal to 69 kilometers per hour. And then this whole shooting match with 22 degrees east, 22 degrees north. Going to erase this triangle. Truck's full of dynamite. Want to get blown up. And we need to divide that by delta T, which is 0.25 hours. And so that is roughly 276 kilometers per hour. My goodness. That's fast. Really fast. Actually, it's not that fast.